A very good afternoon, everyone. I welcome you all to the third and final session of our 3-day workshop on embedded system using Arduino. So, further ado, today we will be dealing with Tinkercad simulations, and it will be handled by our Vice Principal, Dr. KRISHNA KUMAR Kishor, sir. Sir, without any delay, I hand it over to you.
Thank you, Sanjay. Can you hear me?
Yes, sir.
Yes. Okay. All right. Okay. So, good afternoon, everyone. Welcome to this third day of this workshop. Right. So let me just share my screen here. Right. Right. So welcome to this third day. Right. So I hope you found the yesterday session useful. I went through the questions. Sorry, I saw your responses, and I think in general, most of you are getting, out of 10, I think 7 or 8. Right. I hope you got. I hope you got your response mail as well. Did you get your marks? Did the attendees get their marks? Who did the test yesterday? Yes, no? Yes? No?
Yes, sir.
I had returned the scores. Did it? You got it. Okay, all right. Great. Okay. So today what we're going to do is, today we are going to do a little bit of example. So in one sense it is hands-on. I know most of you are going to use this from your mobile phones or viewing this on your mobile phone. So you may not be able to do it as I show it today. But what I encourage you to do is after today's session, if possible, if you can do it on a laptop or a desktop, please try it. That will be helpful for you. So the expectations from today's session is first is to introduce Tinkercad and how to use Tinkercad to simulate an Arduino environment. Right. So yesterday we talked about an Arduino environment. We talked about how there are hardware components, there are software components. We talked about some of what is the input, what is the output, what is the brain behind the system, and things like that. And so so that's so today we're going to use a Tinkercad software, right? Or it's an online application, right? To simulate this Arduino environment. And to simulate it, we are going to basically go over some examples, right? Now, before I start off with, how many of you have used Tinkercad before? Can I just see the responses? How many of you have can someone post on the chat box? If they have seen Tinkercad before, just so that I know what audience I'm dealing with. Has anyone? There are about 49 people. Has anyone played around with Tinkercad before? No. Okay. Okay. So it seems like most people, about 4 or 5 people have responded. One person has used it before. Okay. All right. Okay. All right. So that's useful. Thank you. Just so I can gear my talk accordingly. Right. So this is the website for Tinkercad. If you just search on Google, just type in Tinkercad, and the first response you get is going to get this. So, so this is what its website looks like, and I have kept it open as well. Right. So this is what will happen when you log into Tinkercad. Right. We'll talk about all this. Right. I'll play a video. Please let me know if you're able to hear it or not. Right. I'll play this video. Please let me know if you're able to hear it or not. I tried embedding this video from the website. it doesn't work, we'll go onto the website and do. No. Some reason it's not. Right, okay, it's playing on the web browser here, okay. Let me just turn off my camera, maybe that might help. Right. Okay, let me know if you're not able to hear it. Okay. This is there on the Tinkercad website, right? So you can always play it again. But I thought I'll just play it here so that you have an idea. Um, mm, Second, or maybe it's maybe let that load in the background and maybe we'll move on. So basically, Tinkercad is sort of this simulation tool, right? Quite sure why it is not working. Let me try just one more. Okay, let's move on. Maybe by the time that page loads. So this is how the website for Tinkercad looks like, right? Oh, it's directly going off to this. Okay. Okay, anyway. I'd like to show you that. Some reason it's not playing. Anyway, we'll come back to that later on. Okay, so it's just it's there on the Tinkercad website, right? If you just scroll down a little bit on the website, you'll see it, right? Oh, okay. Right. Please let me know if you're able to hear. Are you able to hear this? Were you able to hear? Yes, no? I paused the video
Yes,
now,
sir.
but are you able to hear the audio?
No, sir.
You're
No
able
audio.
to hear it, okay. No audio, okay, all right. There's some loading time for the video. Let's move on, right? We'll come back to this video at the end, right? So main thing is, so once you go onto the Tinkercad website, so it's a free, it's a free. You can sign in and create an account, and it's free, right? You don't have to pay anything, right? Now, once you log in, what will happen is you will get something like this, right? Once you log in, so I logged in with my my account that I had. Can you share can you see my screen? You can see my screen, right?
Yes, sir. Yes, sir.
Yes. Okay. All right. So all you just got to do is you just go there, log in, create an account, and then after you log in, you will get a page like this where you can do Tinkercad is not only useful for electrical designing, right? You can also do mechanical models, right? So you can create a new design, and you can see something like this, right? You can create some drawings like this, and you can draw 3D models, and you can directly if you see that intro video, what it tells is, you can directly offload that drawing to a 3D printer, right, if necessary, right? In our context, today we are not going to use the 3D design option. What you're going to do is you're going to go to the circuit model, right? The circuit is where you're going to do for electrical designs, right? It can be used for mechanical modeling and electronic circuits. And the main thing, there are a lot of solved examples and projects. So if you go onto the main site, if you go on to learn, right, you'll see a lot of new examples, right, that are there, and it's quite helpful, right? You can do some small projects right off the back, right? You don't have to know anything, right? And it's made such that this entire Arduino one is made such that people with a little bit of basic interest and a little bit of technology focus, they can start using this. So school students can do it as well, right? So what this is what we are going to do, right? So we are going to work in the circuits aspect, because we are doing we are doing interested in the Arduino environment. So the 3D modeling is also possible. So for those of who are mechanical students over here, they can look into that. Right. Okay. Uh, Now, so this is just a screenshot that I thought I'll put in, right? So this is what we'll have. Now, let's go on to some examples today, right? We talked about a lot of code and things like that yesterday, hardware components and things. So we'll go through, 6 examples today, depending on how. I presume, I hope we have enough time for the 6 ones, right? And I'll show you. These are simple, very simple examples, right? It's sort of cumulative. After every example, we are going. For the second example, we are going to use the knowledge we used in the first example, and so on, right? And every example is trying to convey a sort of separate concept, right? So we'll see some coding aspects today as well. Okay, so these are the 6 examples. The first example is we are going to turn on and off the built-in LED on the Arduino board, right? This is a very simple example, and pretty much the first example that everyone does when they're doing Arduino, right? So this is the first example that we're going to do. We are going to program the hardware such that it will turn on the built-in LED. Remember, if you recall from yesterday's discussion, the built-in LED was connected to pin number 13. Right? So via code, we are going to control that. The second example is we don't want to simply turn on and off the LED. We want to blink it, right? We want to blink it at a certain rate, right? So that's what the second example is going to do. The third example is very similar to the first one, but instead of the built-in LED, we are going to use an external LED, right? That we're going to connect, right? Now the fourth one again is related to the second one, but instead of simply blinking the built-in LED, we're going to blink the external LED. The fixed example that we're going to talk about is we now I don't want to simply control the LED via code. I want some human interface, right? So we're going to turn on and off the LED using a push button, right? So we'll see that. And then lastly, we'll also see how do we control the brightness based on a potentiometer. So, right, so we'll see what a potentiometer is and things like that, right? So these are the 6 examples that we're going to talk about. And so this is a good set of examples that convey some basic concepts that you can utilize for, for your further programs and things like that. So let's start, right? The first one. So the objective of the program, right? For every program, every embedded system, there must be an objective. There must be a purpose to that, right? So we're going to turn on and off the built-in LED on the Arduino board, right? So we'll talk about these key points, right? Let's go on to the Tinkercad software, right? Right. So this is the the models that we talked about, right? So there are several starter examples on how to do it, right? So you can go through this when time permits, right? All right. So let's close this and let's start. So what we're going to do is we're going to go to circuits, right? And we're going to create a new circuit, right? So I already have some past designs that I taught or did, just simple examples. So we're going to create a new circuit first, right? Sorry, just 1 second. Just one second. The internet is a little slow over here today. So let me just see, maybe there is an issue or not. Just give me one second. Right. Right. So before let that load up. Right. Before we do that, um, let's write the code. Let's see the code for this example. Right. So this is what I do is typically, I create for the 6 examples. I have 6 folders. Right. I just put up. Um, Now this is a software, the Arduino environment that we talked about yesterday, right? And this is the code that we are going to go. Right. Okay. So we're going to turn on off the built-in LED. So remember, the main, when you're designing an embedded system, you have the software portion and the hardware portion as well, right? So I'll show you the software portion first, right? We'll make sure that there is nothing wrong in the software, right? The code that we are writing, either syntactically, the logic part we can only test when you're testing along with the hardware. So we'll do the software for all the 6 examples. We'll do the software part first. Then we'll go to Tinkercad. We will make the corresponding hardware, and then we'll try running it and then see what happens, right? Okay, so this is a simple example where you want to turn on and off the built-in LED, right? So first we'll turn on and then we'll turn off, right? So let's try I'll show you the code for this, right? So by the way, people who are familiar with C++, we'll know that this refers to comments, right? So anything I write with after this / is a comment. This is a comment, right? So the compiler will not read anything that is a comment, right? So I hope most of you are familiar with comments, right? Every programming language has a provision for comments, right? Comments are useful because it will improve the readability of your code, not only for yourself but also for others as well, right? Primarily it is for the programmer itself, because typically after some time we will forget why we wrote that code, right? So it helps the programmer as well. So once you do that, you turn on and off the built-in LED, right? The purpose of this is to turn on and off the LED, right? And this is a setup function, right? Remember we talked about 2 functions yesterday, right? The setup function and the loop function, right? So the code is pretty small, not very long, very little logic, right? So the first function is a setup function. Again, the setup function, if you recall from yesterday's, it runs once, and the purpose is to initialize everything, right? Now, in our case over here, we have told that we want to have the built-in LED as the we want to blink the built-in LED. So the built-in LED is connected to pin number 13, right? That also we talked about yesterday, right? Now, so what we're going to do is, the first thing that we're going to write is pin mode, right? Pin mode is a built-in function, right? It's a built-in function that takes in 2 parameters, LED built-in and output, right? So what it takes in is, let's go, I'll also open up the Arduino reference one, right? So it's always useful when you're writing. So we are going to use the built-in function that we are doing is pin mode. So first thing you're doing in the setup is you're telling that this pin, so LED built-in is a keyword. It refers to 13. LED built-in is a keyword, and that is assigned to 13. So you can utilize the you can either set this as 13 manually, right? I can also write pin mode 13, and then I can set it as an output, right? This is also possible. Both these are equivalent statements, right? So let's look at the reference file for pin mode, right? So in the functions, if you click on pin mode, right, it will tell you, right? So the syntax is pin mode. You would want to, there are 2 inputs to this function. One is the pin number, and the mode, whether you want it as an input or an output, and it's written over here, right? Right. So the pin is the Arduino pin number, right? And the mode is whether you wanted to set it as an input or an output, right? In input pull up, we will not be using this now. Most of the time, we set it up as an input or an output, right? So now in our case, we want the LED to blink, right? So that means that pin is, we are going to connect pin number 13 to the LED, right? So that means, that means we are saying that, the LED is an output, right? So that pin number 13 is an output, right? It's from there we are connecting to the output device, right? That which the output device in this case is an LED. So I'm writing, both these are equivalent statements. So in the setup, all I'm saying is this using the function pin mode, pin number 13, set it as an output, right? Or I can also set it as with the keyword built-in, LED built-in. And again, you will find that in the set of keywords. And I think it was over here somewhere. It's not here. Right, LED built-in, right? The variable LED built-in. So that's a built-in constant, right? Right, so that's a built-in constant, right? So that's the end of the setup function, right? So I'm going to comment this out, right? So I'm going to write my code, right? So I'm setting up the function. I'm setting, all I need to do is, that's the only thing I'm doing in this board. It's a very simple example. I'm going to say that I want to set the pin mode as pin number 13 as an output. So that's what I'm doing. Make sense? Questions? Questions? Yes, no? Questions, comments? Do you follow? Okay. All right. The next one is the next function that we have is the loop function, right? The loop function, which is a function that we said runs over and over again, right? This runs on forever, right? And all we're saying is, so this line of code is void loop. Remember, void means that this function is not returning anything. So we are writing the function void loop within braces, right? Within open braces and closed braces, right? We want to turn on the built-in LED, right? So what I'm going to do is, let's comment this out, right? So I want, I'm writing, so when the code is executing, it will come to this line of code. It will say digital write, right? Digital write is is a built-in function, right? I'm saying the digital write takes in two parameters. One is the pin number that you want and what you want to write on the pin, right? So the digital write, I want to say pin number 13, which is LED built-in. I want to set it to high because I want to turn on the LED. And that's what we're going to do. So I'm going to say that, digital write. Why digital write? Because there is a digital read, there is digital write, analog read, analog write. Right? We are writing digital write because we are connecting it to the digital pin. If you remember from yesterday, right? If you remember from yesterday's session, right? These were the digital pins on the top, right? So this built-in LED is what we are going to blink. Right, this built-in LED is connected to pin number 13. So we are going. So there is no need for a connection. There's already an internal connection between this pin and this LED over here. Right. So that's all. That's the end of the code. Now this comment I wrote because when you want to turn off it, we'll be doing it. Does this make sense? Yes. No. Hello. Can you hear me?
Yes, sir.
Yes, sir.
Okay, I'll appreciate some response on this side because otherwise otherwise I will not know whether you're understanding the code or not. Right. So in this case, the loop. Do you follow this code so far? Void loop, digital write. Is the code fine? Does it make sense? Okay. All right.
Yes, sir.
Okay. So right. So so in this case, then what you're going to do is, so once you finish writing the code, what you typically do is you compile the. Now for doing that, what you're going to do is you're going to go to you can go to Tools, Sketch, and go Verify and Compile. And then you'll see the other option of upload as well. So we will not be uploading it because we are not connected to any hardware right now. Right, so we're simply going to verify and compile it. Right, so let's do that. Right, so it says over here, right, compiling sketch. Right, so it's compiling this code. But you see some progress bar that is happening over here. Right. So you see that coming up over here, and then so we'll see. We'll just give it a few minutes. That's it, right? So it has done compiling. It says that the sketch has used this much and so on, some information as well. But main thing is there are no syntax errors, right? Let's say for example I forget the semicolon, right? If I forget the semicolon and I go verify compile again, right? It gives an error, right? So it gives an error that's saying that there is a semicolon missing, and it will also, right? So it also tell you, in this line number 21. So you can see the line numbers over here, right? If there's an option for setting up the line numbers, right? Go to line. There is an option over here. I think you can even set it in the preferences, I think. But anyway, what it tells is that this is a syntax error, right? It's telling that it expected a semicolon. So I have forgotten a semicolon over here, right? So this is what I do, right? So in case you made a mistake, the compiler catches it. It tells you that there is a mistake, so you go back and correct it, and then again you check, right? Verify compile. Right. So done compiling. Right now there is no problem. So our code is fine. Right. Now once this is done, what you can do is you go on to Tinkercad. Right. So this is once you create a new circuit, this is what happens. Right. So I'll just rename this. Right. So June 2021 workshop. Right. Example 1. Right. This is the first example. Right. Right. So I think because the net is slow, so because you're working online, I think it'll take some time. So you'll see over here that all changes are saved. So it'll take some time over here. So I think it might take some time to rename it. But anyway, so now we are ready with the code. The software portion is ready, right? Right. So it renamed it as example 1, right? So the software portion is ready. Right now we need to put in, we need to make the hardware part, and also we need to write the code, right? Now let's do the hardware part first, right? So this is a simple example, right? What we need to do is, so there are these components that you can search over here, right? And if you just go basic components in the first option itself, if you just scroll down a little bit, you will see the Arduino Uno board, right? So all you need to do is you can drag and drop this board over here, right? Right. Okay. I put it twice. Okay. I think because of the net, I think it's a little slow. So right. So I just need one device over here. Right. Okay. Right. So this is the Arduino Uno board, right? And in this particular example, so you see that this is the exact layout as what I showed you over here as well, right? This one. This is a Uno board, right? So you're going to write code into this microcontroller. right? Now, again, we are simulating this environment, right? So there is no, so this is a USB cable that is coming in over here, right? This is your the reset button. This is your DC supply, right? These are the transmitter receiver lights. This is the lights that are going to turn on when you power on the board. Here are the digital pins. Here are the analog pins, and so on, right? So what we're going to do is now what we're going to do is right, when you click on this code option, Tinkercad has two ways you can do code, right? So for people who don't know coding or not familiar with coding, they can do it via these blocks, right? So it's sort of, easy, right? You don't have to do, there are, it's like an English language. You can just say, set the spin to high and so on, right? But for our purpose, we will not be using blocks. We will be using text, right? Text is where you're going to type in the code, right? So there will be a default one code that is there. So we'll delete that, right? And what you're going to do is you're going to copy paste the code that is simply typed over here, right? Because this code you already know works, right? You have already done a compile, you have done the compiling part, so you know it works, and you're simply going to copy paste the code, right? So now the code is here, right? We know that there is no syntax mistakes in this code, and our objective, like we told, is to turn on or turn off the built-in LED. In this particular example, we are going to turn on this LED over here that you're going to see, right? So once you copy pasted your code, just start simulation, right? So you'll see that it is turned on, initialization has happened, right? It's initializing, right? And then you'll see that it's going to run, right? So let's wait a few minutes, right? Right. So you saw that the simulation has started running. So the simulation time is happening, right? You can see the timer increasing. You can stop the simulation if you want to, but you can see the main thing is what is happening is the LED has turned on, right? So this LED has turned on, right? Can you all see it? Yes, no?
Yes, sir.
Yes, sir. Yes, sir. It's turned on.
Right? Okay. All right. So you can see that the LED is turning on. Now, what is actually happening, right? When you run start simulation, right, or start the simulation, this code runs, void setup runs, and it is run once, right? It's run only once. Now, what is being run over and over again is this void loop, right? So every time you're coming into this loop, right? This code gets downloaded into this microcontroller, right? You see that the USB is now connected, right? The USB is now connected. You see that this light is turned on, so the board is powered on, and you see the orange light, the built-in LED that is flashing. Not flashing, that has been turned on, right? So what is it doing, right? When the code, what it is doing is every time you enter this void loop, it is seeing this statement: digital write, LED built-in as high. Right? So every time I'm running, remember this code is being run continuously by the microcontroller, right? So every time what you're doing is you're setting this pin number 13 to high, right? And that's why the LED is continuously on, right? So now we're going to stop the simulation. Right now, I want to turn off the LED. So what I'm going to do is I'm just going to edit it over here, right? Right. So I'm going to turn on this part of the code, right? I want to turn off the LED. So actually now nothing is going to happen, right? Because the LED is already turned off because you're powered off the board, right? You stop the simulation, so you see that the USB is disconnected, right? The board is not powered on. There is no green light here, right? And now I'm going to run the simulation again, right? Right. So let's wait a few minutes. Right. So you see that the simulation has started running, but there is nothing, there's a sort of, nothing much to see here, right? Because what you're doing, you have turned off this LED, right? So you see that the LED has turned off now, right? Why is it turned off? Because every time you're running this code, it hits this line, right? You're writing digital write, right? Digital write again, you're writing to this pin, right? This pin, LED built-in pin, you're setting it to low. Right, that means low again. Remember, low is 0 volts, high is 5 volts. Right. Again, if you want, you can look at the built-in functions. Right, you can see that digital write. Right, this is a reference function. right? Right. So you see that it takes two values, the pin and the value, right? So the value can be, the argument can be either high or low, right? And the pin is the pin number, right? So that's it, right? So this is a very simple code, right? It's not much. So I'm going to stop the simulation here, right? So you see that the USB got disconnected, right? Board is powered off, right? So it's not much of an it's not much of a embedded system per se so far, but it's a starting point, right? We are able to control this built-in LED over here right now. Okay. So let's go back to the slides, right? Right. So what have we seen so far in this example, right? We're turning on and off the built-in LED. So you're seeing the keyword LED built-in. You're seeing what it means to go as a high and low, right? High is 5 volts and low is 0 volts. So remember, why it is we're using these keywords as high and low is because it's more user friendly, right? So not everyone needs to. You don't need to remember what is the exact voltage value and things, right? So the other functions that we saw is pin mode, right? Pin mode is used in the setup function, right? To set up the pin as an input or an output, right? So we're setting it up as an output, right? So you see that, right? This LED, this pin is connected to this LED, so therefore it is an output, right? You're seeing that the digital write function, right? So again over here, if you look at this, the digital write function, you're telling it which pin and what value to write it to, right? So that is the digital write. And again, note that the loop function is running forever and ever, right? So that's why this is this program is keeping on running, right? So the microcontroller is continuously running this program and is running this function again and again. Okay, so that's all about the first example. Questions? Is that clear? Does that make sense? Yes, no?
Yes, sir, it's clear.
Okay, all right, thanks. Okay, all right, okay. All right, so the second example that we're going to do is we're going to build upon this, right? Turning on and simply switching on and simply switching off is a little boring. We'll make it a little bit more interesting. What we're going to do is we're going to blink this LED at a rate of 1 second, right? So every 1 second, so 1 second it turns on, 1 second it turns off, 1 second it turns on, 1 second it turns off. So it looks like a blinking part, right? It's turning on and off, right? So let's see how to do that, right? So let's go back to sorry, Balamurugan sir, can you mute, sir? Right. Right. Okay, so let's go to the second example, right? The second example is example 2, right? Again, the same procedure, right? We'll first write the code over here, and then we'll do a syntax check, right? Making sure everything is working fine, and then we'll copy paste the code, and then we'll do the hardware, right? So here again, in comments, what I have is you're going to turn on and off the built-in LED at a certain rate, right? We can decide what the rate is. So in the question or in this example, we have tried two ones. One is at 1 second and at a rate of 5 seconds. So let's do this. And right, so there's already a built-in example, and it's very similar to that, right? So in examples, if you go under basics, there is a blink example, right? So you can try out all these examples, right? So, but once I try to write my own code, so I understand the code as well, right? So this is the same as a blink example, right? And again, now the setup function is not changing, right? Everything is the same as the previous one in the first example. The setup function, we are saying that the pin mode, I want to the built-in LED, which is LED built-in, I want to set it up as an output, right? So no change over there, nothing much to change. Now here is where the loop function is where things start to change. Remember, the loop function is running over and over again, right? So this is the portion where the logic part comes in, and right. So what we're going to do is, we are going to turn on the LED. So what do we want? We want to turn on the LED. Then I want to wait for one. I want to turn it off, right? Then turn it on, turn it off, right? Now to get this appearance, right? Because this code is executing very fast, right? Because remember this happens at almost the clock cycle speed, right? So for us to visually see this, right, we must have a certain amount of delay, right? So let's do this, right? So I want what I'm going to do is I'm going to turn on the LED, right? So digital right, LED built in, right? So that means I want to set the pin number 13 to high, right? So when I set it to high, I'm supplying some voltage, right? So when I'm supplying some voltage, the LED will blink. Then I'm going to wait for 2 seconds, right? So in my case, I'm going to turn it for, remember our first example was 1 second, right? So let's reduce that to 1 second, wait for 1 second. Remember, no, all right, so this is the next function that you're going to see. Delay is a built-in function, right? The argument is in milliseconds, right? So when I say 1 second, it is 1000 milliseconds. That's why the argument is 1000. Again, there is, if you go back to the reference file, right over here, you will find the function for delay, right? The delay function, right? So if you look at the description, right, you'll see that it pauses the program for the certain amount of time that you want, right? So the argument is it takes an argument in milliseconds, right? The number of milliseconds you want the program to pause, right? So what happens is, right, how does the code work, right? The code is executing, right? It sees digital write. Okay, fine. So I'll be supplying 5 volts. Then I come over here, right? It sees the delay function. So it's pausing the code, right? So when it's pausing, remember in the hardware, it is already turned on. So the light is on. So I'm pausing for 1 second. Then it goes to this line. Now I want to get the light blinking. Light blinking is nothing but turning on and turning off, right? Then I turn off the LED. So same thing, digital write, the same pin built in, LED built in. So pin number 13. Now I set it to low, right? And then again I wait for 1 second. Okay. So again, I wait for 1 second. So now what happens to the code, right? Let's see what happens, right? When I run this code, execute the code, what happens? Remember, void loop is running continuously, right? So it comes to this line, digital write high, right? Turns on the LED, a delay of 1 second, so it waits. So when it is waiting on the board, the LED is turned on for 1 second, right? Then I come back over here to this line of code, right? Now I'm turning off the LED, right? And then again, I wait for 1 second, right? Because again, I want to get that appearance, right, of a blinking. After this, what happens, right? It goes back up, again runs this code, right? This is what I mean by the code running again and again, right? So unlike simply, regular software programs, typically what happens is once you finish this loop, it exits the program. So in Arduino programming, this is one thing that you need to keep in mind. This loop function keeps running over and over again, right? So after you come to this line of code, it goes back up automatically, and you see the next time it's after waiting for 1 second, it is again going and turning on the LED. Right. So I hope this code is clear. Any questions? Any questions? I presume not. Right. If there are, please feel free to unmute and say it. Right. So again, now what I'm going to do is I'm going to do a syntax check. Right. So go to Sketch, verify, compile. Right. Again, so it's done compiling, right? It gives me that, since there are no red lines, there is nothing to worry about. There is no error happening, right? Another way, by the way, to, instead of going to Sketch and verify compile every time, what you can do is you can simply click on this check mark. So it does a verify, right? Again, over here, if you were connecting it to the hardware, after this check, what you would do is you'll go upload. But instead of this is what we are doing in Tinkercad. In Tinkercad, we are not going to upload it. It's done on a web-based interface, right? Okay, so let's go back to our Tinkercad, right? This example is done. So let me go back. Or maybe I should right. So example one is already there, right? What I already just did right now, right? Now I can create a new circuit, right? There's also an option, if you go on these settings, you can also duplicate a project, right? So if if you're drawn a complicated project with a lot of wires and things like that, and you don't want to redraw everything, you can simply click on duplicate, right? So it will save you some time, right? So what I do is I just as an example, I'll show you a duplicate, right? So I'll click on duplicate. So it's loading, right? So it will create a duplicate of example one. Right, sorry, I'm turning off my camera just in the just to ensure that there is no bandwidth issues. Right, I don't want it to slow down. So if necessary, I'll turn it back on. Right. Okay, so you see that, right? Right. So you see that, right? Because I created a copy, I already see that Arduino mode coming in, right? And I'm just going to rename this back as example 2. Right. I hope it is saved, right? Let's try it. Example 2. It might take some time to rename, right? Example 2. Right. Okay. So I don't have to, I could simply drag and drop back this Arduino Uno board, but I don't need to, right? It's already there because it's a copy. And the code is already built in, right? This code is already there. So this is from example 1 code. So I'm going to delete this code, right? And I'm going to copy paste the code that I typed over here. Right. So this is the blinking code, right? So let's run this code. I know that there is no syntax errors in this code, so I can at least confidently run it. Right. One nice thing about Tinkercad is because you're not connecting to any physical hardware, actual hardware. So even if there is any mistake, you're not blowing up any component here, right? It's only a software simulation, right? So let's turn on this code, right? Let's see what happens. Should have zoomed into that. Let's start this. Right. Right. So right. So you see what is happening, right? Right. Right. So you see this built-in LED over here, right? That is blinking, right? So it is. So you see that, right? 18, 19, 20, 21. Right, 22, it's turning off for 1 second, turning off, right? Turning on, turning off, turning on, right? What do we do? We have only written turn on once, turn off once, right? But this is continuously going on. Why is it going on? Because the loop is continuously running, right? That is what is happening, right? So you turn on, you wait for 1 second, then you turn off, then you again wait for 1 second, go back up, turn it on, wait for 1 second. Turn it off, wait for 1 second. Right? So you see this is happening, right? So so the LED is now blinking, right? So this is the next example that I wanted to demonstrate. So the thing, right? Does this make sense for people? Yes, no?
Yes, sir.
Yes. Okay.
Yes,
right.
yes.
Okay. Right. Okay. All right. So right. So this is the LED blinking, right? Now let's make it. So I'm going to stop the simulation, right? So let's change. Let's do the second part of this example, right? So I blinked it at a rate of 1 second. I want to slow down the blinking rate, right? I want to blink it as a rate of 5 seconds, right? So what do? Right? I'm going to just edit the code here, right? All I need to do is I'm going to change this to 5. 5 seconds means 5,000 milliseconds, right? 5 milliseconds, right? So that's all we are going to do, right? I'm just going to change the delay, right? I'm going, so it will turn on, it'll remain on for 5 seconds. then I'll wait for, so when I'm waiting, right, it's when I'm waiting, I'm getting the appearance that for my eyes to see that it is on for 5 seconds, right? And then it will turn off, right? So it will turn off and then it's go to this line of code. So when it's going into delay, you're waiting for 5 seconds. So that 5 seconds is when it gives the appearance that the LED is off for 5 seconds. Then again, it will turn back on. Okay, so let's run this and see what happens. Right, so keep an eye on the timer over here, right? So it's on for 5 seconds, then now it's off, right? We can start 1, 2, 3, 4, 5. Now it's off for 5 seconds, right? 1, 2, 3, 4, 5. Again, 1, 2, 3, 4, 5. Right? At 5 it comes back up. 1. Right? So you see that now you have changed that delay timing, and now you can play around with this. You get the hang of it, right? So you can make this smaller as well, right? If you want to make it less than 1 second, right? Let's say if you only want it for 500 milliseconds, right? So one thing is you cannot edit the code when its simulation is running, right? So I can stop the simulation. Did you all see this? Yes, no?
Yes, sir.
Right? You see the, right, okay. So you see that the blinking rate has changed now, right? So let's stop the simulation. Let's make it faster, right? Just for fun, right? Right. So again, I changed it. Now it's only 500 milliseconds, right? So that's half a second, right? So you see that the LED is blinking on much faster, right? And that's it, right? So every time you run the code, you see this things that you saw earlier on, right? The USB port, USB is connected, the board is turned on, right? And the blinking rate happens now. Right? Okay, great. So I hope that makes sense, right? Right. Once you get, so that's why, again, point over here is to get you familiar with this board and, get you familiar with these functions, right? So you can write more complicated code on your own, right? Based on the application that you want to do. Let's quickly recap, right? So in second example, the different thing that you saw from the first example is, in addition to the built-in high, low, pin mode, digital write, right? You saw the delay function, right? Where the argument is in milliseconds, right? So let's move on to the third example. Right. So just to summarize examples 1 and 2, right now this, when you talk about this embedded system, right? I say this is an embedded system, but it's a very simple system, right? Now it's sort of oversimplified, right? The embedded system, it only consists of a UNO board, right? There is nothing else really, right? If you look at that, there is nothing else over here, right? And you're controlling this purely by software, right? Everything, only what is there in the code is what you are doing, right? There is really no interaction with that embedded system, right? We are not giving any input to the system, nor are we taking any output from the system, right? With with real world external components, right? Our input was purely in the code, right? And our output is also simply on the built-in component, right? So in that sense, it's a very simple system, right? So there is no external components, wiring or anything. We have not included any of that, right? So let's take a little bit more. Let's take a little bit more of a detailed example. Now, instead of blinking this built-in LED, right? Instead of blinking this built-in LED, what we are going to do is we are going to blink. We are going to connect an external LED and blink that, right? So that's what we're going to do. So let's go back over here and I'll open it up and keep, right? So it's easier. So let's, the loading time can be saved. Right? Right, so again, I'm going to just create a duplicate copy over here. So it'll just save me some time. Right. Okay, so let that run in the background. Meanwhile, right? So some things to know, right? It's not only electronic students that are here, right? I think there are not only electronic students, there are other students as well, right? Just a few things, right? Some basics about so this is the LED that we are going to take, right? And an LED, an LED is a two-terminal device, right? It's a two-terminal device, which is a cathode and an anode, right? Just like a like a battery, right? A battery has a cathode and an anode. So here the convention here is the cathode is a negative one and the anode is the positive terminal, right? And in this Arduino one, it's the anode is this slightly bent wire, right, which is slightly longer in length than than this short wire, right? This bent wire is longer in length, right? So that is a convention. So we must know this. Why? Because we must we are connecting. So an LED is sort of a diode, right? That current flows one way, right? So it's important that we know this, right? So another thing to know is we'll be using a breadboard, right? We talked about breadboards in the first class, right? Now right. So before we go on to the breadboard, so there's one more thing. This LED has a maximum DC rating. It's usually the maximum DC rating is roughly around 20 milliamps, depending on the LED, right? Depending on the brightness that we're talking about, and also depending on the color of the LED, you can have it. And the one we're using over here is a red one, which 20 milliamps is roughly the maximum limit. And another thing that you got to know about is the breadboard and the wiring. So this is what a breadboard looks like, right? And main thing to note is that the green lines that are here, all the holes that you're seeing horizontally, right, on the top and the bottom, right? Sorry, I didn't draw it on the bottom, but on the top line, right, this green line, all these holes are interconnected, right? So if you're plugging in a wire in any of these holes, you'll get the same voltage, right? The blue line in light blue color is also interconnected internally, right? We don't have to worry about it. It's internally connected. So plugging into the second hole is the same as a plugging into fourth hole or the 10th hole or the 15th hole, right? Now the other sort of internal connections are happening is these are this top negative and positive, and this top negative and positive are the only places where horizontally it is interconnected. Everywhere else it is connected vertically, right? So in this row number 2, right, row number 2, these 5 dots on these 5 holes are interconnected internally, right? And these 5 holes on the other side of the board, they are also interconnected internally. This and this are not interconnected, right? So these are two separate ones, right? So row number 2 and row number 3 are not connected, or row number 2 and row number 10 are not connected. Right? So you must make sure that you are connecting components appropriately. Right. Okay. So these are some background things that you must know. And right. So another thing is we'll be using a resistor. This is quite common, right? Well, why we're using a resistor is because we want to limit the amount of current. If you don't have a resistor, right? I didn't include the circuit diagram. I should have maybe in hindsight included it, right? But if you draw a basic circuit diagram, what is going to happen, right? You will have the circuit diagram that we're going to draw is maybe let's see if I can draw it. Just give me 1 second. The basic circuit diagram that we are going to draw is right. So let's say the basic circuit diagram that we're going to draw is right something like this, right? I'm going to have a resistor and then I'm going to have an LED. This is a standard symbol, and this is the circuit that we're going to draw. Right, so this is our LED that we have, right? And so we need a power supply, right? A DC supply. We need to have the LED, right? And we know that this is positive and this is negative from the LED. This from the LED what we talked about. That is this one, right? The anode and the cathode, right? So this is a simple thing that we're going to draw, right? This is what we need, right? This is a circuit diagram, right? So we're going to do the circuit diagram is always useful because we can use it for wiring our circuit, right? So we need a power supply, we need a resistor, and we need the LED as well. Right now, why this resistor is there is such that you can create sufficient, you can limit the amount of current, right? that is flowing through the circuit, right? Because if there's too much current, this LED will blow up, because LED, there is a maximum current rating for this LED, so you cannot blow up that component. Now, because we are doing it in Tinkercad, one advantage is, you are not going to blow anything up, right? That is one advantage, right? So that's something that we need to know about, and then we're also going to make sure that we wire the circuit properly. Right. So these are the things, the background things that we need to know. So now let's look at the code part, right? So let me open. Let me close the second example. Let's go on to the third example. Right. Right. So the third example. Now what we're going to do is remember, use a built-in LED. We're going to use an external LED. Now, because you're using an external LED, we need to connect it to some port on this Arduino board. Right. So let's see if I opened up or not. Right. So I need to connect it to any of these pins, because, and again, we are only turning on and off. That is why we are connecting it to the digital pins. Right. So I'm going to connect it to one of these pins, and you can decide whichever you want. You have up to 13 options are there. Right. So in this code, I'm saying that I'm going to connect it to pin number 2. So I'm going to, this is pin number 2. It is to this pin that I'm going to connect my LED, right? So what I want is, I'm going to define a global variable, right? Remember we talked about global variables yesterday, right? So the global variable is of integer type, right? Because I'm just going to take in, I'm going to set it to 2. So 2 is an integer, right? So the variable that I'm using is LED pin, right? So this is a global variable, right? Right. And again, I don't. I'm going to have the setup function and I have the loop function. The setup function is pretty simple, right? All I want to say is, all I have is I want to initialize. Again, right now here, note that we are using LED pin, right? What I'm saying is, LED pin will get substituted for 2, right? LED pin, I said that variable's value is 2. So the pin number 2, I'm setting it as an output. Why output? Because again, I'm connecting an external LED, so it should be an output, right? So this is why we use variables, by the way, right? Because suddenly I want to change, like for example, in this case, let's see, I have how many instances of LED pin I have? I have here, here, and here, right? So if I want to make any change in my circuit later on, I just need to change this number, right? So if I change this 2 to 4, everywhere automatically it will get changed, right? So so that's why it's good, people who do programming, that's why we use variables, right? So if you change in one place, automatically everywhere else, it's it's just good programming style, right? Okay, so that's about the setup function, right? It's a void setup, right? Nothing is getting returned, right? So I set my port number 2, that is this pin. I have instructed the board, this is something that must be set up as an output. Okay, now it's the same code. No code has not, the code has not changed, right? As example 1, right? We go to void loop, right? All I'm saying is turn the external LED on. I'll comment this because this is for turning it off, right? So I'm going to write digital write LED pin high. Right now, instead of in example 1, it was a built-in LED, which is pin number 13. Here it is pin number 2. Right. So all I'm saying is set pin number 2 to high. Right. So from the code point of view, nothing much has really changed. All you have done is you're going to change the pin to which you're connecting your component. Right. That's all that has changed. But the logic of the code is exactly the same. Right. So let's compile this and see if there is any mistake. So let's go verify. I'll click on this check mark. Right, nothing done compiling, right? No problems, right? So that's fine. So my code is syntactically it's correct. Now let's go on to the hardware part, right? So again, this I have created a duplicate copy, right? You can zoom in and out of this, right? That's what I was doing just now. I'm going to rename this, right? Example 3. Right, and just take some time to. Right, let's wait a bit. Maybe it may, right. So it has changed it, right? So okay, example 3. Now let's see what are the components we need, right? We need the Arduino board. This is the brain part. I need to connect a power supply, And instead of connecting a separate power supply, which you can also do from Tinkercad, right? There are power supplies available. We are going to use simply the power supply from the board. There are power supplies going on over here, right? I mean, the pin itself is a power supply, so we don't really need any other separate power supply, right? So let's do that, right? So let's design this hardware part first, right? So let me drag and drop a breadboard, right? There are two breadboards in here. If you see, there is the breadboard small, and I think there's also a breadboard large. So for us, small is fine, right? So let's drag and drop this, right? So we have a breadboard, right? Now, what do we want to do, right? So we're going to work with these pins over here, right? So I'm just going to put it a little bit up so that wiring is a little easy, right? Okay. So what do I want to do? I want to connect, right? So I have the now I also need an LED, right? So let's search for an LED. Right, here we go. Right. So I'm going to right. I'm going to connect this LED, and I'm going to connect it, say, let's say over here, right? Right, and also this is a nice thing, right? If you look into it, if you just hover around this, it tells you that this is the cathode and this is the anode, right? So you know which is the anode and the cathode, right? So we said that this is the anode, so we need to, and now we also need a resistor, right? So remember, this is a circuit diagram that we are drawing, right? Just so that just stay consistent with what I have drawn already. What we'll do is we'll put the circuit, we'll put the resistor after the LED. It doesn't really matter, right? But just so that right? So I'll put the resistor here, right? So this is a circuit diagram that we're drawing, right? So I need a piece of wire that goes from the positive side to the anode, then one from the cathode to the resistor side, and then from the resistor back to the power supply, right? So let's do that. So let's also place the resistor, right? So I need a resistor, so let's place that, right? And then right, so this happens. So I can just place a resistor there. So I'm placing it at two different points, right? It's important. Why? Because if I do this, this is wrong, right? I think people in electronics will be knowing this, because all the ports are internally connected. All these holes are internally connected. So it will, as though that this resistor is not there. It will simply go through the wire that is there underneath the board, right? So I need a potential difference on two ends of the resistor, right? So this is I have all the components that I have wanted, right? Now let's do the wiring part, right? So let me just right. So what we're going to do is we are going to go from pin number 2. Right, I'll draw from here. Pin number 2. Can just draw this right over here. So I connected to here. This is the positive side, because I'm going to turn this as a positive part, and then I'm also going to I'm going to change the color of this so that it's sort of convention, right? You put the red as a positive wire, right? Then what we're going to do is we need a ground as well. So we're going to connect the ground from here. This is the ground in the board, right? Turn over here, and then we're going to connect it to here. And typically ground is always given black, so we'll turn it to black, right? Then what happens, right? So now I've connected to the board, right? So this line is completely black, which is ground, and this line is completely the reference 5 volts, right? Now I want to connect this to the LED anode, right? So I want to draw a line all the way from here to here, right? And I'm going to just give it as a separate color. All internal connections we can give it as a separate color. I'm going to give it as a green color. So the current goes from the board, it goes to this line, goes from here, goes all the way through this wire, goes to the anode, comes out through this cathode part. And then I want to draw a piece of wire from, let's say I can draw from anywhere over here, right? I'm just going to draw from here all the way to here, right? So I connected, so the current goes from here like this, goes to this, goes to this, comes out through the resistor. Now I need to connect the resistor back to the ground supply, right? So let's connect that over there. That's it, right? So this is a simple circuit that we have drawn, right? So we have connected an external LED, right? And this is a circuit that we have, right? If you want, you can put whatever color you want, right? That doesn't matter, right? And right, you want to change the value of the resistor. The default resistor value is 1 kilo ohms. We can leave it as that. It's not a big problem. We'll just change the the intensity of the light, right? I'll change it to the setting that I have mentioned over here. I will change it to 200 ohms first, right? Doesn't matter. Do that 200 ohms. 200 ohms, right? So that's the value of this resistor. So you click on it again, it will say that it's 200 ohms, right? Okay, so that's all regarding the hardware part. So I don't think we have made any mistake. Of course, sometimes mistakes can happen, and that's one good thing about Tinkercad, right? Even if you make a mistake, you're not burning any component, right? The simulation will not give you the expected output. That's all, right? So now the hardware part is done, right? Now we need to copy paste a code. So let's copy paste the code that I had. So I'll delete the code over here. Example 3 code. Right. So I copy pasted that, right? So LED pin 2, right? Just make sure it is LED pin 2, right? Connections look fine. Let me see. Let me just run it and see what happens. So right now it's going to turn on this LED and it's going to keep it on. Right. So let's run this. Just wait a few seconds, right? By the way, does this make sense to people? Yes, no? Oh, right. Okay. So simulation has started running, right? So simulation started. So you see that the LED has turned on, right? This LED is continuously turned on, right? You see that, the board is powered on, USB is connected, right? We are not turning on the built-in LED, right? So this is not blinking. This is not turned on anymore. We are turning on rather the LED that we wanted, right? So that's fine, right? So that's what we wanted, right? By the way, any questions, comments so far? Does this make sense?
Yes, sir.
Yes, no?
Yes, sir.
Yes, okay, all right. Okay. Okay, so let's stop the simulation, right? So board is powered off, right? Now let's go back to the old one, right? I'm going to turn off this. I'm going to turn it off. Now nothing fancy is going to happen, really. Nothing is going to happen because it's already off, right? But just for the sake of completeness, we'll run it, right? So nothing is going to happen as expected because the LED is off, right? So we're just continuously writing to this pin saying that keep turn off that LED, right? Or it's always supplying. I'm always supplying digital write 0 volt, right? So I'm continuously writing 0 volts. So therefore there is nothing is happening, right? So let's stop this, right? Now let's turn this back on, right? And then let's just change the resistor value, right? And it was 200 ohms. Let's just change the resistor value to 1000 ohms. Right, let's run it and see what happens. Right, so you see that it's oh sorry, I didn't turn on anything. Okay, the entire code is commented. Sorry. So right, let's turn this back on. Right, resistor value is 1000. Right, I'm going to start the simulation. Right, so you see that the intensity of the LED is slightly lower than when we had 200 ohms. Right, if you look at 200 ohms, it blinked a little bit more brightly, right? It's because the amount of current that is being supplied, the amount of current has gone down because the resistor value has increased, right? Now, just to show that, what happens, let me make this very small, right? Let me make it, 100 ohms, right? Right, let's just make it 100 ohms, and let's start the simulation again, right? Right, so immediately you see that it's turned back on, it's brighter, right? Let's make it even smaller and see what happens. And so let's just make it 10 ohms. Right? So you see an exclamation mark coming up, right? So what does it say? Right, the current through the LED is 45.5 milliamps, while the recommended maximum is 20 milliamps. So therefore, the usable lifetime of the LED will be reduced, right? So it's a warning message for us, right? So that's good to know, right? Right. So that's the importance of this resistor here, right? So by changing that, the resistor value, the amount of current is, so the current has increased. As the resistor value goes smaller the resistance, more the current, right? So, but there is after all, this is a device. Every device it's an electronic component. It will have a certain rating to it. Right? So that's about that, right? So now, so that is a very simple example, right? So what have you seen? Right. So we have seen the use of global variables. You've seen assigning the desired, you've seen, connecting the LED to some desired pin that we wanted. Now let's build on this example and continue on with the second example. Now I want to blink this external LED, right? So I'm going to blink the external LED. So let's go back to our code. So let's go back over here. Let me just load it and keep. Right, so I'm going to create a duplicate copy of this, so I don't have to do the wiring again. Right. While this loads, let's look at the fourth example. Okay, so the code is exactly the same as the third one with some modifications, right? The modifications that I already told you earlier. So the LED pin, again, I'm going to connect it to the second pin, no change in that. And the setup function, I'm saying that, I want to initialize it as an output, right? In the loop function, now is where what we did, right? So I want to wait it, I'm going to blink it at the rate of 1 second, right? So I turn on the LED, the loop is running continuously. First I say, digital write the LED pin high, so it turns it on, then wait for 1 second, so the LED is on by this time, then I'll turn it off, right? And then again I wait, and then again this code runs, right? So nothing, this is very similar to the second example, but only thing is now instead of the built-in LED, we are going to connect it to the external LED. So again, here you see from the code point of view, nothing much has changed, but the hardware has changed. So let's verify this code. Right, so it's compiling it. Again, it's done compiling, so no issues, right? So syntactically, everything is fine. Now, let's rename this, right? Example 4. Now, our hardware also has nothing has changed, right? The circuit is exactly the same. We don't have to change anything, right? It's the same wiring, but the hardware is not changing, but only the code is slightly going to change. Right. So I'm going to delete this code that we had. I'm going to copy paste the code that we just wrote over here. Okay. So this is LED pin 2, right? It's connected to LED pin. Now I want to blink this LED at a rate of 1 second. So let's start it, right? Oh, I didn't change the resistor value, so you'll see that error coming in again, right? Or the warning coming in, right? So let's stop the simulation, right? Let me change the resistor value. So let's change it to a reasonable one. So let's change it to 200 ohms, right? And let's start the simulation again. So let's see what happens, right? So you see the LED is blinking now, right? At the rate of 1 second, right? So you see, look at the timer as well, right? 12, 13, 14, 15, 16, 17, right? So 1 second is on, 1 second is off. So this is the appearance that it is turning. So what you're really doing, a blinking LED is nothing but turning on and off at a certain rate, right? So let's stop that. Does this make sense? Yes, no? Okay, all right.
Yes, sir.
Right, okay. Just in the interest of time, we are almost at 1.5 hours. Do you want me to continue, or should we stop this with 4 examples? We have 2 more examples to go, which are the main part, I think. But if you want to stop, we can. It's up to you. What do we want to do? Are the participants okay with continuing? I'm okay. There is no. For me, there is no problem. Can we continue, or should we wait? Should we, stop here? Okay. All right. So by the time we take a decision, let's just summarize what we did for third and fourth example. So this example, so this Arduino board is a little bit more. This Arduino, this embedded system is a little bit more complicated than the initial system that we taught. So it consists of a Uno board. There's an external LED. There is a breadboard. There is a resistor that's controlled by software. Right now, over here, there is very limited interaction with the real world. Right. What I mean by that is, there is only an output. You see an LED that is blinking, but that is controlled by software, right, or code, right? You're programming it to do something, and you can see the output, right? We used some basic components like wires, resistors, and breadboards, and some basic knowledge of electronic circuits that's needed to put together circuit or to wire the circuit, right? Now again, right? So the next examples 5 and 6, what we're going to do is, here there is only the output is there to the LED system. From the embedded system, there is only an output, right? Now in the example number 5, what we are going to do is, we are going to have a user input as well, right? We are going to add a push button, right? Then it becomes a fully embedded system, right? So there becomes, there is some human interaction, and based on that input, we can, based on that input, we can control the LED. Right. So, by the way, what's the feedback from participants? Should we continue or should we not continue? Anish sir, Sanjay, what should we do?
So I think continue, sir.
Okay. All right. Okay. So I'll continue that. Okay. All right. Okay. So so our objective for this program is, we want to turn on an external LED using a push button. Right. So when I press a button, it's like a switch, right? An electrical switch, right? But just, it's right. When I press this push button, I want it to turn on. When it comes off, I need to, when I do not press a button, it should turn off. Right. Now there are some things that we must know how to do when you're doing this. Right. That is, we must know what is a push button doing. Right. So that is a little important. Right. So push button basically is a 2-terminal device, right? So even though it looks like there are 4 terminals, right? When this is a screenshot from Tinkercad. Even though it looks like there are 4 terminals, there are only 2 terminals, right? So I'll call this as, if you look in Tinkercad, it's named like this: 1A, 1B, 2A, and 2B. Now really there are only 2 terminals. With these two, 1A and 1B are interconnected, right? Essentially, they are short-circuited. Right? So you'll get the same potential either over here or over here, right? And 2A and 2B are also interconnected, right? So for our point of view, what we're going to do is, we're going to use maybe, let's say, terminal A as the input, right? And terminal 2 as the output, right? So, but I can take the output from 2 places if I want to, right? From here or from here, right? That's what, so we'll see that. Right, so that's what I've written over here. Terminals 1A and 1B are internally connected, and 2A and 2B are also internally connected. So, so that's about the push button, right? So let's. So again, on the push button as well, again, you will be using a resistor, just so that just so that the circuit doesn't just go off to ground, right? Just so that there is some control that you can do on the. It's like a pull down resistor that you're adding. Right. So let's do the hardware. Let's see the code for it first, right? So let's close this. Let's go see example number 5. Right. Okay. So now what we're going to do is, right. So we're going to turn on an external LED. Again, we're going to stick with an external LED when a push button is pressed. Right. Now the external LED is connected to push button to pin 2. So the external LED is connected to pin 2, but the push button, right? Push button is connected to pin 6. Okay. So that's what we're going to do. Okay. Okay. So these are again, now we're going to have two global variables, right? We are setting LED pin. So the pin to which, or the digital pin to which LED is connected is 2. And the digital pin to which push button is connected is 6. Again, push button is connected to a digital pin because, we just need to turn on and off based on the voltage supply, right? The supply that is coming in. All right. So, what we're going to do is we're going to set up the board, right? We're going to say that, LED pin is an output, right? So I'm going to, so on pin number 2, I'm connecting the LED. So in pin number 2 is connected to the LED, so therefore it is an output, right? So from that port, from pin number 2, power supply is going out of the board, right? Whereas pin mode, the push button pin, the 6th pin is an input pin, right? So that is the input to the system. We are feeding the voltage is coming into the Arduino board via this pin. If I press a button, if the circuit is closed, right? What happens when you press the switch button, right? So if you want to go draw a circuit diagram, right? It's something like this, right? Again, you're going to have a supply, right? Right, this is your circuit, and again you're going to have an LED, right? This is what happens when the circuit is closed, right? Again, sorry, you're going to have a resistor here, right? Right, when the circuit closes, right? When you push the button, the circuit closes and the LED will turn on, right? So because it's when the circuit closes, the input goes into the system, right? The embedded your system knows that, oh, I got an input to the system, right? So that's why you want to right, so that's why we are setting it as an input, right? So this is conceptually a little important, right? When we understand why we are setting it, why we are setting certain pins as an output and why certain pins as an input, right? This is so I hope that is clear. These are two important statements, right? Now these two statements are not really very important. It's not necessary as well, but if, I just set it such that initially I want to make sure that there is no floating voltages, so I just set it to low, such that I'm writing to that pin it is a 0 volts, right? Okay, so that's the end of the setup function. Now let's look at the loop function. Right, this is the loop function. Again, it's not long, it's a very short piece of code, right? So this is what, right? So I don't need this. This is what I was doing yesterday, right? So, okay. So what I need to show is, right? Check if the push button is there. So remember this loop function is running continuously, right? In the back of your mind, that must be there, right? It's running continuously. When the line of code is getting executed, it executes line by line. So when it comes over here, so what do I want? I want to first check if the button has been pressed or not. Right? If the button is pressed, I want to turn on the LED. Right? If the button is, if I open the switch, right? If I open the switch, right, that means the button is not pressed. I want to turn off the LED. Right? And then again, I come back and I'm waiting, right? So I want to. So here we are going to see the if condition. Right? Remember the if condition, we saw this yesterday. I'm having an if else condition over here, right? And what I'm going to do is I'm going to check if so now we're going to use a digital read over here, right? Because it is an input, the push button is an input, right? So far we have only seen digital write, so I'm going to use a digital read function. So this is reading from that pin, right? I'm reading from that pin, from pin number 6, right? I'm checking that whether, so this function, let's look at the digital read. Let's look at the Arduino references, right? If you look at digital read, right? Digital read, right? So it reads the value whether it is high or low, right? And it returns a high or low. That is important, right? In this function, returns something, right? As opposed to a digital write. A digital write doesn't return anything, right? You're just writing to it. That function need not return anything. A digital read returns a high or a low value. So that's important, right? And the argument it takes is a pin value, right? So let's go back to here, right? So what I'm going to do is digital read push button pin, right? So this function will return whether I'm reading on that particular pin, right? Let's go back over here, right? Let's say it's pin number 6, right? In pin number 6, I'm returning, checking if there is a high or a low voltage coming in this pin, right? Right. Right. Well, let me just, create a duplicate copy and keep as well. Just in the interest of time, I'll create a duplicate copy and then edit it. Okay. All right. So meanwhile, let's come back to the code, right? So I'm going to check if it is a high or a low, and then I have this equal to, which is checking, right? So if it is high, right, I'm checking if the digital pin is high. If it is high, do a digital write, right? Write to the LED pin and say that it is high, right? So I'm checking on pin number 6, but I'm writing to pin number 2. Right? To pin number 2, I'm saying that it should be a high, right? If this is false, if it is not, if the button is not pressed, in which case this condition will be false, right? If this condition is false, don't execute this set of code, execute this code, right? Digital write, pin number 2, I set it back to low, right? So the logic is pretty simple, right? It's a pretty simple logic, right? So let's verify the code, right? Right, no errors, so everything is fine, right? So now let's go and do the hardware part. Okay, so the hardware is going to be a little bit more, I want to make some more changes to the circuit, right? So let's do that, right? So I want to, I'm not going to give a pin, I'm not going to give an input directly to the LED. So I'll delete this wire, right? What I need is I want to have a switch over here, right? And we have a push button, right? So push button, I'm going to place it over here, right? Remember, it's important that you, again, one thing that I must tell you is I recently found this out, right, from lab, from Satyan sir, right? There are options, you can rotate these components as well, right? I've not seen it, but I'll just show it to you, right? So let's just pick a resistor and just placing it over here, right? And if you press R, the component rotates, right? So you can have that. It's just an information for you, right? So, you may not always want to place a component vertically, right? So you can rotate it as well. Okay, so for our purpose, we're not going to do anything like that. So we just keep it like this, right? So I have a push button, right, which I'm placing on two sides. So so this is what I told you, terminal 1A, terminal 1B, terminal 2A, and terminal 2B. It's important that one and, these are at different terminals. So these are at different voltages, right? So what I'm going to do is I'm going to supply, let's go back to the circuit diagram, right? Right, the positive end goes to a switch, right? The input of the switch. So the input of the switch, let's say terminal 1 is the input, right? So I want to draw a piece of wire from here to, to this over here, to here, right? So this is the input of the switch. Terminal 1 gets gets an input, right, of 5 volts, right? Right. So the LED pin is right. So this is the this is supplying the power, right? Now on the output side, right? What do I want, right? So on the output side, what I want is I want to take an output from the switch to the LED, input of the LED. So that is also needed, right? So here what happens is, right, what we need is we need a control signal to go from the push button to pin number 6, right? This is slightly important when you're drawing. When you're from the electrical diagram point of view, it's like you're drawing from the output of the switch. You're directly going to the input of the LED. But from really what we have is we have our embedded system in here. We have the Arduino board over here. We have the Arduino board over here. So if this is happen, if the switch is closed, it goes into pin number 6, right? Pin number 6, and the output comes out through pin number 2, right? So that's what I need. So I'm going to connect the output from here to pin number 6. So let's draw it at right angles. It's somewhat at right angles. Right, and just to differentiate this, we'll give it another color. This is a logic line, right? So we'll just right. So right. So this is what happens, right? So right. So now what do I need? So based on so what happens if there is an input coming in, I have a supply going on over here. Right. If I press the button, there is a control signal that tells pin number 6 that okay, I'm going to read from this pin. Right. I'm going to keep on reading from this pin. Right. And if it is true, right, what I want is so this line I want to change, right? What I'll do is so we'll use a separate power source, right? If this is true, I get the input through this orange colored line, the board decides, and then writing an output from here all the way to so let's right. So let's go through this again, right? If the output comes through the push button, it goes as an input. Maybe I'll change the color of this so it becomes a little more clear. Let's put another color. Let's put blue color, right? So the output comes from the push button that goes as an input to the board, right? So I'm reading from pin number 6. If the button is pressed, I'm telling set pin number 2 to a high voltage. So that voltage goes into the input of an LED, and then the usual circuit that you saw, right? It goes into the LED, comes out, goes to the resistor, comes back out, and it goes to the ground over here. Right. So now I hope that is clear. Right now, what we did remove was the power supply line for this one. So let's connect a wire to it. Right. We'll connect a 5 volt. We'll connect a 5 volt line. Right. So let's connect a 5 volt line. Right. As a 5 volts as input. So let's do that. And this is an input. So I'll connect it a red colored line. Right now, this is fine, right? From an an obvious point of view, this is okay. Now, from a circuit point of view, what you need to do is you also need to connect a resistor. It's sort of otherwise what happens is let's see what will happen. Right, when you're pressing this, right, there is current that is going to flow through here as well, and there will be some floating values over here. Floating voltage at the other end of the circuit. So you need to ground the push button, right? You need to ground the push button as well. So that is also important, right? So what we'll do is we'll place a resistor, right, over here. We'll place a resistor, and the value of the resistor can be some, it can be a reasonably, can be a high value. Right, we'll leave it as 1 kilo ohms, right? No problem, right? And it's connected back to ground, right? So these two are the why this is needed is because otherwise, the voltage over here for the push button point of view, it will be floating, right? So that's why we need a resistor, right? And we cannot give it needs to be a decently high value, because if it's not a very high value, a lot of current will flow through this output and it'll go directly to ground. right? So nothing will happen. I'll show you a demo of that. So there must be a reasonably high value such that there is very little current flow leaking away from the circuit, right? And it right. So that's it. So that's the hardware part. Now what we need to do is we can copy paste this code that we did. So let's delete this code. By the way, let me rename this as example 5. Example 5 code. Paste it. Right. Right. By the way, any questions so far before I start running? Questions? Yes, no? Okay, all right. So let's run this, right? So this is a little bit more, let's see what happens, right? So this is the same code, right? And let's start running this. So start simulation. So let's just wait, right? So it's, right. Right. So nothing is happening right now as expected because nothing is, it's not expected that anything is happening. You're only expecting something to happen when you press the push button. Right. So let's see if it works. Right. So I'm going to press this button. Right? You see the light blinking. So a second, I just want to zoom in so that you see it properly. Right. Okay. Okay. So let's zoom in. Right. So I'm going to click on this push button. Right. So when I press on this button, right, you see that button is depressed. You see the LED is turned on. Right. When I leave it, it is off. Right. Right. Is that visible for you people? Is it clear? Right. So it's pressed now. I'm leaving it. Right. So what is happening in the code, right? Right. So let's go through the code, right? The code is also equally important. This is the thing about an embedded system, right? It's not only important that the code is working fine, but it's important that the hardware is wired properly. It's also important that your hardware performs just like what you wrote in the code, right? So it's important that you understand the code as well. So let's see what is happening, right? The loop function is running infinitely, again and again, right? So it is coming to this line of code, this line number 30, right? It is seeing this, it's continuously checking if it is high or not, right? So right now I have not pressed anything, so therefore it is low, right? So nothing, so it's always executing. This LED pin condition is low. So that means I'm always writing to the blue line, right? The blue line is pin was pin number 2, right? If you remember this, right? LED, the blue line is connected to pin number 2. I'm always writing LED pin to low, right? So that means the blue line is continuously I'm writing it is low because I have not pressed the button. Now, if I do press it, what happens? Whenever so I come to this end of this line of code, and again I go back up, right? Again, it's checking for this if condition, right? Now it is checking. So if I do press it, this condition becomes true. And for the duration of which I'm pressing it, right, remember this code is continuously happening, right? It keeps on writing high, right? So let's see that again, right? So when I press it, right, I kept the switch is pressed, right? So again, in this condition, it's always happening. It's always true. So it's always running that. It runs a digital write high, comes to the end of the line, goes back up. Again, it checks. Again, I'm pressing it. So again, it's high. So it keeps on doing that. The moment I leave it, right, the condition becomes false and it becomes low. You follow? Yes, no? Yes? Make sense? Do you want me to explain this again? I guess not. Okay. All right. So I think with that, I think we'll stop. I think it's about, I think it's a little bit of overload of function, overload of information. So why the other example is maybe, let's see if I have an example here. So I'll stop the simulation, right? So I'll just show you. We're not going to go over it in detail, right? I'll just show you the sixth example, right? So anyway, just to summarize, example number 5, right? We have right. I'll just tell you why this else condition is equally important. Let's see what happens if I do comment this out. If I comment it out, right? So that means this code is not going to run. Right? Let's see what happens. Right? This is sort of errors that can happen. I'm telling you this because I made this mistake, right? Initially I thought, oh, it's not needed. Why is the else condition needed, right? Let's see what happens, right? So the code is exactly the same, but I removed out the else condition, right? So LED is not blinking, right? Now I'm going to press the switch, right? So it's on, right? So the switch is on, LED turns on, but I left the switch now, but the light is still blinking. Why is that, right? Why is that? Is because from the point of view of this switch, the condition is it's only checking, right? Nothing is wrong syntactically. Everything code is correct. Everything is correct, but your embedded system is not performing the way you want it to, right? So there's no syntax errors in your code. Why? What happens is because once you have written a digital write as pin, right? Sorry, the digital write you have written LED pin to 2. The LED pin, the second pin, as high, right? You continuously set it up as high. You are not pulling down that voltage, right? So that is why the else condition is there. So always, even if you leave the button, this condition is false, right? So nothing will happen. But from the board point of view, the board is already supplying to 5 volts to this, and that is continuing. You're keeping on supplying that voltage. You have not told the board to bring down the voltage. So this is one error that you think everything is set up fine, but it doesn't. Your system doesn't work like the way you want it to. So the reason is this, right? So that's why embedded system programming is a little different conceptually. In your mind as well. You must understand that there is a slight difference, right? Rather than regular programming, right? In regular programming, this aspect you don't have to worry about, right? Whether the voltage is turned back off or not, right? So in that sense, it's a little important, right? So I'm going to stop the simulation, right? I'm going to turn it back on, right? So again, I started back, right? Again, now it should work, right? Now I pressed it. The moment I leave it, I have told the board to bring it back to 0. That's why it works. Okay, so that's about example number 5. Right, so we talked about the if and the else condition as well, and the resistor and the push button. Now the next one is I'll quickly go over this. I'm not going to go over the code in detail, but what we're going to do is right now we're only turning on and off the LED. Right, what we'll do is we'll control the LED with a potentiometer. So I want to control the brightness of the LED. Right, and just so that you know, a potentiometer is a three-terminal device. Essentially, in first year, electronics people learn this. So you have terminal 1, terminal 2, and you have terminal 3, which is sometimes also called as a wiper, right? So it's a potentiometer is nothing but a variable resistor, right? So this is what you're going to do, right? So you're going to it gives you a continuous range of values, right? Now the main thing, because of you're using a potentiometer, right? You're going to and you want a range. You're continuously turning this knob. When you're continuously turning this knob, you're not simply doing high and low. You're reading a range of values. And that's why what you want to use in this case is an analog in pin. You're not going to use a digital pin, you're going to use an analog pin. So, right, so you're going to read, now to read from the potentiometer, you're going to use an analog pin. So that's why the analog input is important, right? So I'll show you that, right? I'm not going to go over and just in the interest of time, not in much detail, but and then the output also, it's important that you use a PWM pin, because you cannot you're going to use a digital pin, but you cannot simply set it to high or low. You want to control the intensity of the light. So you want to use a PWM pin. So we talked about PWM pins earlier on, right? So a PWM modulation is nothing but a technique to get analog results with digital means. And you can just refer this on the site. There are some details, right? So I'll quickly. I'm not going to go over the code. I'll just quickly show it to you since we are on this anyway. Right. So example number 6. Example number 6 is. I'll just quickly go over the code and I'll just show you the working demonstration. Right. So the LED pin now, we are going to connect it to pin number 9, right? Because this is one of the PWM pins. Right. Let's go back to the diagram. Right. So these are the PWM pins. Right. So these are the PWM pins, right? So see the ones with the tilde sign. So I can use only the this as an output. So I'm going to use pin number 9, and I'm going to use the analog in over here, because the potentiometer is going to give a continuous analog value, right? So the analog pin that I'm going to use is A0 pin, right? It's the A0 pin that I'm going to use, right? And the LED output is going to go from pin number 9, right? And initially I'm just going to set the value to be, I'm going to read from the potentiometer. Initially I'm just setting its value to be 0. Again, see that the LED is set up as an output. Initially I'm just going to set its value to be low. Right now, here is a new function. Right, I'm going to read from the analog pin. So I'm going to use analog read. Right. Now, one thing that you need to know is when you're reading an analog value, you can give out a value between 0 and 123. Right. But when you're writing an analog write, that will take on values only between 0 to 255. Right. So very quickly, what it's simply doing is this input value is going to map between a value between 0 to 120, 1023. You're going to map to 0 to 255. And gives you a mapped value. And then you're going to write that analog, you're going to use the analog write function. So these are two new functions that you're seeing, analog read and analog write. Right? So you read from the potentiometer pin, you write to the LED pin, right? This mapped value, right? Don't worry too much about this, just take my word for it for now, right? So I'll quickly show you that setup. Right, I think I already, before this, as part of preparing for this workshop, I set it up, so you can just see that. I'm not going to draw it again. Right, so this one over here. It's so I'm not going to spend time explaining the hardware part, but it's pretty self-explanatory, right? Let's just wait for this to load, right? And we'll directly run this, right? Just in the interest of time. Right. So you see the Arduino board. We see that the resistor connections or the LED connections are exactly the same, right? LED, you have a resistor that is going to ground, right? You're taking a 5-volt supply, right? You're going to one end of the variable resistor. You're taking the output from here that is going to ground. The variable voltage comes in through this wiper connection. That is what you're feeding as an input to your embedded system, A0 pin. So this is the blue line as an input, right? And the output depending on this input that is being sensed at A0, you write the output through pin number 9. Right? Again, this is a PWM pin. Right? So that code that I just wrote over here, I'm just copy pasted it over here. Right? So this is pin number 9 and the A0 pin. So let's simply just run it and you can see the output. Right? Right. So as of now, nothing is there. I'm just going to turn this knob. Right. So depending on the depending on how I turn this knob. So if I turn it to the extreme right, it is off. If I turn it to the extreme left, it becomes a maximum intensity. So I'm controlling the intensity of my light. It's simply not binary anymore. It's not simply on or off, right? So depending on, this is a variable resistor. So depending on the resistor value, the voltage that is coming out from here will change. So that is being sensed to this embedded as an input to this. So since it's an analog value, right? Because it's a continuous range of values, right? So that's why you're using the analog in. And depending on this input, I turn the voltage over here, right, from the output side. So here the resistor, right, so it's a very low voltage, right? So it's spitting out a low voltage. So therefore the LED intensity is very low, right? If I turn it, right, if I turn it back up, right, this is the maximum setting. So this is the maximum value over here. This is somewhere halfway through. You can see that the intensity of the LED has come back down. Right. You just zoom in as well, so you see it. Right. So this is off. Right. The LED is, there's pretty much nothing happening. Right. I turn the resistor knob over here. It turns with somewhat is there. Turn it very much, and then the intensity is a maximum. Right. So I think we'll stop with that. Right. So that's about example 5 and 6. Why I show example number 5 and 6 is because, just to summarize that, right? This is really it's a little bit more complicated of an embedded system that we saw initially. There is both an input to the real world, which is a potentiometer, and there is also an output. Right. In our case, the output is an LED. Right now. Right, and so we have also used some components. So this is sort of beginning to look like a proper embedded system, right? Based on some user input. Like for example, your embedded system could be a robot, right? You're saying that when you raise your hand, the robot should also raise your hand or raise its hand, right? So that is an input and output, right? So the input you're showing is you're raising your hand. So the sensor, in that case, the robot example, there must be a camera that is, or some IR sensor that is capable of sensing that you have raised your hand. Based on that input, you are going to turn some motor on the robot arm, and such that the robot raises its hands. Right. So this is sort of an input and output. So in our particular case, it's still a very simple example, but we are controlling the intensity or the brightness of the LED based on the potentiometer. Right. So just to summarize what we have seen over these 3 days, right? We have seen what we've seen today is we've seen 6 examples of embedded systems using the Arduino board, and that achieves various functionalities, right? Depending on what we wanted the embedded system to do, right? And again, remember, we have simulated all of this in Tinkercad, and you can do the exact, once you know the wiring is done in this Tinkercad, you can copy paste this exact wiring in hardware as well. When you come to the lab over here, you can do the exact same thing, right? And again, for more intermediate and advanced users, there are much more things that you need to learn. Concept of libraries, like for example, in C or C++, we do a hash include, some library. You can do that as well. Concept of serial port, I have not talked about it. Shields, I told you about this. Memories, functions, having more than one function. Right now, we are only using 2 functions: the setup function and the loop function. Right, and there's much more. Right. So I hope. So with that, I think these are some references. The Arduino website, and personally, I learned a lot about this. On this Coursera courses. Right, these 3 courses: Introduction to Internet of Things and Embedded Systems, the Arduino platform and C programming, interfacing with the Arduino. And this is a book. I think it's freely available. right? It's electronic circuit basics with Tinkercad, but you can search for it online, right? And there's some useful information over there as well, right? So students who are interested in it, you can look through these, right? So the purpose of this 3-day workshop is, just to get your feet wet programming. So we have talked about the programming aspects, right? We have seen digital read, digital write, analog read, analog write, delay, the loop conditions and so on, right? And of course, if you're interested, you can always do more examples, right? And with that, I think I'll conclude. So it's about 2 hours. I'm sorry for taking this long, but I hope it was useful, right? So thank you very much. So that's all I had. Right, so this is a photo from our campus, by the way. The lake houses. Okay, so that's it. If there are any questions, I'll take it up. If not, we can wind up. So Sanjay, I'm done from my side.
Okay, sir. If there are any queries, you can unmute or you can post it in the chat session. Okay, since it is too long, I would like to invite the another coordinator of our 3-day workshop, Kavya Mukundan, S6EC, to propose vote of thanks.
Good evening, all. It's my pleasure to propose the word of thanks on this memorable occasion. Let me, first of all, start by giving glory to the Almighty Lord for making this occasion a resounding success. First and foremost, I thank the Vice Principal of Ahalia School of Engineering and Technology and one of the resource persons of our workshop, Dr. KRISHNA Kumar Kishor, sir, for his kindness, interest, and continued support. Thank you, sir. Next, I would like to thank the second resource person of our event, Assistant Professor of Electronics and Communication Department of Ahalia School of Engineering and Technology, Mrs. Shweta C. Thank you, ma'am, for your patience and cooperation. I thank our well-wisher, Head of Electronics and Communication Department, Dr. V. Balamurugan, sir, for his unstinted support and commitment. Thank you, sir. I owe special gratitude to the HODs of other departments and all our faculties who have worked hard to ensure that this occasion becomes a memorable success. Thank you all. Last but not the least, I thank all our participants for your cooperation and energetic supports. Once again, thank you all.
Right, I think I'll add, I think I must also thank Anisa for coordinating this. It's been in the works for quite a bit long time. So I'd like to thank Anisa also for coordinating this. So I sincerely hope you students found it useful. And I'll also add that, the second part of this workshop, we'll try to do it in the college, when you come back, whenever it is possible, right? So that time, we can do it over there. So I hope you got a good understanding. I hope at least for the third years, when you wanted to do your to find your project and things like that, I hope it is useful. For others as well who are doing, projects at home and things like that, I hope it will be a good starting point. Thank you.
Feedback link is in the chat section. Please fill it for attendance. And thank you for having you all.
Oh, sorry, one more person I forgot to thank is Satyan sir, lab assistant. He has also been very helpful. So I'd like to especially thank him as well. Okay.
Participants, if you have any questions,
Thank you.
you can ask. Participants, if you have any special query, you can ask.
Okay, Anisa, I think if there are any questions, I'll take it later on. I think it's been 2 hours. I think they also probably fed up of it. Okay then. I'm going to exit the meeting. Okay. Thank you.
Okay, sir. Thank you. Thank you, sir.
Thank you.